Greeting from Stanford University. I'm Bill Barnett, professor at the Stanford Doerr School of Sustainability and the Stanford Graduate School of Business.
Hi everyone, my name is Gulbin Atli, and I am studying electrical engineering at Stanford.
My name is Milian Chen, and I'm studying Earth Systems in the Biosphere track, also at Stanford.
And we have with us here today some professors from the Stanford Doerr School of Sustainability who just ran a conference here at Stanford on seafloor science in Central California, research frontiers and collaborative opportunities. Gentlemen, please introduce yourselves.
Well, my name is Steve Graham. I'm a professor in the Department of Earth and Planetary Sciences. Also, I had the privilege of serving as the Dean of the School of Earth, Energy, and Environmental Sciences from 17 to 22, at which time that school became an integral part of the Doerr School.
My name is George Hilly. I'm a professor in the Department of Earth and Planetary Sciences.
Also chairing that conference were Professor Rob Dunbar, Professor Andrea Fildani, and Professor Kristen Davis. So George and Steve, thanks for being with us today.
Thanks very much for having us, Bill.
Absolutely. And maybe we'll start off, Gulbin, Milian, you're familiar with the conference proceedings and papers, and I know you have some questions.
Yes, we do. Throughout the conference, the one thing that I realized is that the ocean was presented both as a solution to climate change and as a system that is highly vulnerable to disturbance. We heard about carbon storage and alkalinity enhancement, but also about mining and warming impacts. So my question is, do you think there is a risk that we begin treating the ocean primarily as a tool rather than as a system with limits?
So thanks. Good question. And that represented sort of the last element of the conference where we particularly focused on ecosystems. And I think there are big concerns there. And I think several of the talks highlighted that very clearly. For instance, the talk by the new director of the Monterey Bay Aquarium Research Institute, Nambari, spoke about the occurrence of metal-rich nodules on the seafloor in certain areas, and about the long-lasting impact that mining that might happen here would have on the seafloor, and particularly about its recovery of ecosystems thereafter. And it's pretty clear from her talk that the effects are quite long-lasting based on experiments they've done. And I think the world in general, and certainly even people in our field, haven't yet fully absorbed that message. And I think her paper is just fantastic in terms of spotlighting those potential risks, unintended, but nevertheless quite significant.
One thing that stood out to us during the conference is often speakers emphasize uncertainty. We heard about plume transport, larval connectivity, and ecosystem recovery thresholds. And after hearing all of these talks, where do you think the biggest unknown is right now? And if you could fund one major collaborative research effort coming out of this conference, what would you want it to focus on?
Boy, Milan, that's both a great question and I think a pretty big question as well, because there's so many domains that intersect with the ocean and the interface between land and ocean. There are huge uncertainties, for instance, about how climate change itself will actually impact the delivery of sediment to the coastline and the ocean system, as we have perhaps a change in the intensity of precipitation onshore in some areas, which can cause additional flooding, the delivery of sediment, the increase in factors such as wildfires within the areas where sediment that is carried by the rivers is actually generated. This can also profoundly alter beaches in these very punctuated events, which can disrupt not only the proximal coast areas, but also the delivery of materials to the nearshore environment, where they can also impact ecosystems in those areas as well. The real challenge, I think, that was brought to the forefront during the conference is that a lot of these processes that interface land and ocean happen at fairly long repeat times. That is that they're pretty infrequent. but extremely impactful when they do happen. And we expect both their impacts and frequency to increase as climate change alters those effects. But at the same time, the rarity of the important events can actually create a situation in which they actually become very hard to predict and forecast as well. And so that's a substantial uncertainty that I think exists, is how the long-term impacts of human-induced climate change actually create the punctuated or change the frequency and magnitude of punctuated events, which change the interface between land and ocean. And I think that those, and how all of the downstream systems are basically affected by that, the ecosystem services, et cetera. And so I think that that's a real area that needs a lot of research in the future, is how to actually get our hands around understanding how these very impactful, very infrequent events might actually change, and how these impacts will propagate through both the kind of physical and biological systems within the kind of ocean-land interface. And it did seem as though scientists from the USGS, scientists from MBARI, the Monterey Bay Aquarium Research Institute, and many of the other local institutions actually found some fertile ground for trying to think about these types of problems together as an outcome of this conference.
And I might add to that, one of the great things about the way the conference was set up was sort of the middle section of reports was largely geared towards the documentation of the naturally occurring tempo of processes that happen without regard to humans. And so set against that background, then you can begin to evaluate these effects that humans have caused as well, so that you get the full picture of how the environment is impacted and changed both by naturally occurring phenomena and by what humans do.
That is incredibly interesting. And for the sake of our audience, I want to drill down a little on what you two have just said. As I'm understanding it, some events that happen are quite frequent, and so they're easier to forecast just because they're happening a lot. What would be an example of that type of event?
So, for instance, there are like seasonal weather patterns that could be shown to intensify over time, over a relatively limited time series. How those interact with the Earth's surface in terms of triggering large magnitude landslides that might, again, generate products that are ultimately impacting the coastline. How these, for instance, dry spells create enhanced wildfire over the decadal timescales, and how this produces, enormous amounts of sediment generation when combined with these large magnitude precipitation events. Those are all things that, how you can actually see the perhaps observable increase in cadence of different types of, atmospheric phenomena interact with the longer term kind of very large impactful events that the sediment delivery system, such as rivers, actually delivers to the coastline and modifies the coastline in those cases. I think those are some interesting examples of how there are these short, kind of regularly occurring impactful events that then can act to additionally modulate these, kind of longer term, these more infrequent, high magnitude, extremely impactful events.
And I'd like to amplify something that is the background to all of this. So the only way you can know about these events in 3,000 feet of water, for instance, is through technology. And an important point of this whole conference was to lay out the recent advances in our ability to detect things in 3,000 feet of water on the seafloor. And it's extraordinary what the technologies are now. For instance, it's possible now using automated underwater vehicles to map the seafloor in features that maybe are only an inch high, and to be able to photograph those as well. And one of the amazing examples of that was shown, and this is again MBARI technology, was the discovery of this octopus garden on a seamount in really great depths of water, where they've mapped, and they got some good publicity about this, 6,000 octopi living in they're very small features too, living in specific areas where the water's a little bit warmer because of geothermal activity, and has allowed them to essentially to breed in that locality. Never before would it have been even remotely possible to know they exist, let alone to image each individual octopus and to count it as well. So that was really one of the goals, and sort of the first third of the conference is to sort of lay out the amazing things that are done now.
And not to put too much of an explanation point on this, but I remember, or we all experienced the wonder of watching, for instance, NASA rovers land on the surface of Mars and actually begin observing these very foreign environments. And really, some of the things that I saw at that conference were comparable in terms of the novelty, the complexity of the technology, the automation, the robotics that are going on to actually be able to, observe things in such an unstudied and foreign environment as the deep ocean floor. And it was absolutely amazing to see the types of technology that the U.S. is in general developing, but some of the oceanographic institutes and some of the academic institutions in the area are also developing. It's quite extraordinary.
I just wanted to quickly say, I remember seeing the octopus garden on the news, and when I was younger, I used to watch some of the dives that MBARI had. And so when I saw it on the news and everyone was talking about how important and cool it was just really inspiring moment to see like the research is being like told to everyone and it is being spread. So it's just a really inspiring moment.
Well, to that point, we have had a long, successful relationship with MBARI here at Stanford, and many of our students have gone on to work down there and internships. A number of my students, graduate students, have done dissertations based on MBARI data. You might look into that. There could be some really interesting opportunities for get some time on ship or to work with some of the robotics and so forth. So yeah, check it out.
Thank you. Yeah.
And Milian, also just to tell you my own story about that, my 11-year-old daughter compulsively watches these MBARI videos just as you did when you were young. And I think what is extraordinary about a conference like that is that not only did you get to see it on the news, but you got to see the news delivered by the people who discovered it themselves in the room in front of you. And that, I think, is a real special thing.
The room where it happened.
So speaking of technology and seafloor, a recurring theme was how much of the seafloor remains undermapped or understudied in the conference. In many cases, we are still learning what these ecosystems even look like and how do we define a baseline for systems we are only just beginning to understand. And can we responsibly regulate something before we truly know what its undisturbed state looks like?
Yeah, I mean, I think that's a very good point. And just to elaborate a little bit more, the octopus garden was a wonderful example of what's possible. But, it takes a very long time to create these surveys at that scale. And to scale that up to the ocean is, well, quite frankly, impossible right now, although it's obviously an aspirational goal. But again, to go back to, for instance, the manganese mining example, seafloor mining example, we really need resolution at the seafloor at that level to know what's out there. And there are vast areas where we just don't know that. So, people are trying to chip away at that. But quite frankly, it's going to be a very challenging thing to get that level of detail for the whole of the ocean. At that point, then you have to decide what's good enough and what are the critical areas where you really need to have those kinds of data.
I think as we talk about the different ways like the ocean is studied, there are like many ecological processes that we heard about on timescales of hundreds of thousands of years. Unfortunately, or in just as a result of policy and economic decisions happen as just a few years. How can scientists communicate this mismatch in timescales more effectively to policymakers and the public so it matches up?
Well, that's a good question, Milian. And I guess what I would say is we can raise many of these issues, but we also need help. We need help from people like you. Our wheelhouse is really in how to make these measurements. What does it all mean? How do we structure studies in order to provide the baseline that Gulbin, you were talking about, in terms of actually having like a baseline for monitoring change and understanding impact. And I think it is an extremely important endeavor to be able to have an interface between that process of discovery and characterization and the policy making that ends up going on. Because in many cases, scientists, as you've seen over the years, we can be a reserved bunch in terms of being very obsessed with levels of uncertainty and being able to honestly and to the greatest precision possible characterize the types of systems that we can understand and then what we don't understand. How to translate that into a policy framework is also an interesting and necessary skill set that would really benefit from kind of a layer of study between the kind of hardcore science that was being presented at this type of conference and how that gets translated into specific actionable policies, within regulatory agencies.
And if I could add to that, well, I think there are a couple of areas where scientists need to do better. As George has said, we do well speaking to each other. Conference kind of showed that, I think. But one thing is we need to get out there with more information that's digestible by the public, that is basically real science and not basically clickbait stuff. And there's obviously a lot of fake news out there. So that's something that needs to happen. We aren't very good at that, so we need to interface with journalists who have the ability to do that. People who are graduating, for instance, from your program, Earth Systems, are the kinds of people who potentially are in the position to do that. The second thing is, as George has intimated, but I would like to get more specific, is we need to interface with legislators better than we have. And one of the great things about the Doerr School is that there are lots of people in the Doerr School who are doing that sort of thing. So we have now some nice ties with the government in Sacramento, particularly with regard to groundwater, as for instance. We need to do more testimony in front of Congress as well. So I think if we steadily make progress on those two fronts, disseminating science at a digestible level to the public, and also getting together with legislators, getting in their face if necessary, to get these critical things apart, then we will have done what we need to be doing.
No, that's great to hear. And George, Steve, when I first got to know you guys and the other folks in the Stanford Doerr School of Sustainability who work in the broad area of oceans from all different scientific perspectives, I was completely blown away with how important the ocean is. Now, many of our listeners, we all know the oceans are vast, but could you help us, before we end the podcast, just understand the importance of the ocean?
Sure. And, the oceans have been taken for granted. And that was underscored by one of the talks in the conference about how, we've viewed it as an inexhaustible supply for, seafood. We've used it as a dumping ground forever, as if it didn't matter, as if it was inexhaustibly recoverable kind of asset. And clearly it's not. Big as it is, some of the changes take quite a bit of time, but on human timescales, we do things pretty quickly, and clearly we have made an impact with regard to climate change on the oceans. It's already detectable, and so we need to again go back to what I just said, do a better job of making sure people understand that in fact the oceans and everything they contain are not inexhaustible, nor are they immune to damage that is potentially immutable that we as humans are doing.
Well, thanks so much for that. So, Milian, Chen, Gulbin, Atli, George, Steve.
Thank you.
Many thanks, Bill.
Thank you so much for taking this time. And to our audience out there, until next time. The Stanford Initiative on Business and Environmental Sustainability podcast series is sponsored by the Stanford Graduate School of Business and the Stanford Doerr School of Sustainability. Music by Charged Particles. That's Caleb Hutzler, Mike Rock, and John Krosnick.